Hello everyone. In this video we are going to talk about how to solve modulus inequality or absolute inequalities. How to solve them? Well, in order to talk about how to solve these kinds of inequalities, let's have a short review on what the concept of absolute value is. Okay, suppose we have a function, like let's say y is equal to absolute value of 2x. Okay, so in this case, let's say if x is equal to 1, positive 1, therefore y will be equal to 2, the value of y. Yeah, okay, but if x is equal to negative 1, again the value of y will be equal to 2. So here we can draw a conclusion, and that is, we can say if the value of y is equal to 2, therefore either the value of x is equal to 1 or the value of x is equal to negative 1. So these are possible values, they are possibilities. Okay, when we say y is equal to 2, we don't know exactly x is equal to 1 or x is equal to minus 1. So this is this is the conceptual part of the absolute value, because absolute value deals with the magnitude of the size. It does not include any sign of a number. Okay, but let's now move on to inequalities, absolute inequalities. Okay, we will consider the solution by solving a problem. Okay, let's consider this inequality, which is absolute value of 2x minus 3 larger than 5. Okay, so in order to solve this problem, this inequality, what should we do? So how to solve it? So the simplest way is, first of all, step number 1, we change this sign of inequality to equality. And why we do so? Because we want to find the critical values. We want to find the critical values, and that's why we change the sign to inequality to equality in the solution. So okay, in the solution we can do that, and then we will get the answer based on the inequality. Okay, so this is just a solution, a part of the solution. It doesn't mean that we need to change the question. Okay, so let's go ahead and see how it works. So first of all, I will change it to equality. So absolute value of 2x minus 3 is equal to 5. Now I will say there are two possibilities. There are two possibilities. Either 2x minus 3 is equal to 5, or 2x minus 3 is equal to negative 5. Okay, based on the conceptual part that we just looked at. Okay, now if we solve here, we will get 2x is equal to 8 and x is equal to 4. So this is one of our critical values, and the other one we will get minus 2, x is equal to negative 1. So this is the other critical value. So what we have done, we have found now so far the critical values. So what is the next step? So the next step, step number 2, is to draw an axis. So let's draw an axis now. Very simply, we draw an axis. And then we scale it and we show the critical values on this axis. Okay, simply let's say 0 is here, and 1, 2, 3, 4, 5. Let's go 1 unit more than the upper span of your critical value, and 1 less than the smallest critical value. Okay, and here is -1, and let's go a little bit further, -2. Okay, now we just mark those critical values, but we need to pay attention to the sign here, which is only largest, not largest side, or it's not largely equal. Okay, so therefore we need to show them by a small empty circle. So this is one and this is the other. They are not included in the answer of in this equality, and in order to make sure whether they are not or whether they are or not, we just can check them and see if they satisfy this original inequality or not. Okay, now what is the next step then? Next step is we need to approach these critical values either from this side, from negative infinity, or from positive infinity. Let's approach one of these critical values. Okay, so what it means is by approaching, it means that we need to substitute a value less than the critical value. That means we are approaching it from negative infinity, and if we substitute one value larger than the critical value, that means we are approaching it from the positive infinity. And if they satisfy, either of them satisfies, that is the answer. Okay, so now let's try it and see how it works. I will say if, let's say first x less than -1, it means I am approaching it from here. Let's see it works or not. I will select then x is equal to -2, and then let's see if it works or not in the original equation. Original equation is absolute value of 2x, which here x is -2, -3 larger than 5, and let's see it works or not. Okay, so here in this case to -4 -3 will be equal to -7. The absolute value of -7 is larger than 5, which is correct. So therefore here worked, actually here worked. Okay, this case works. So this part is the answer. That means if we approach the 0, one of the critical value, from negative infinity, this is the answer. But how about the other critical value? Before moving to the other critical value, let's make sure that this area between these two critical values do not belong to the answer. Okay, so let's select one value between these critical values, which is, let's say, 0. Okay, so I say if x is larger than -1 and x is equal to 0, what will happen? Let's check in the original equation. So therefore this will be the absolute value of 2 times 0 minus 3 is larger than 5, which is wrong. So no, not correct. Okay, so therefore here in this area does not belong to the answer. Okay, so let me just color it, make it sure this is the answer. Okay, we just show it in this way. And so here between these two critical values, this area does not belong to the answer, to our answer. So now let's check whether this area belongs to the answer or not. Let's say if the values here, I mean larger than 4, whether they satisfy the original equation, original inequality, sorry, or not. So let's see. If, let's say, x is larger than 4, and why I don't need to check if x less than 4, because I already checked here. Here I already checked if x is larger than -1, it means it doesn't work. So it means that any number I put on here, it doesn't work. Okay, and now let's check if any value larger than 4 works for this inequality or not. Let's go and select, like, let's say if x is equal to 5, okay, and see how it works. Therefore, I will substitute it in the original equation. Absolute value of 2 times 5 minus 3 is larger than 5. Is it correct or not? So it will be absolute value of 7 larger than 5, and that is correct. Therefore, here also is the area of the answer. So here is also the answer. So any number you put on, you plug in the original inequality, it will work. Any number, okay? So, but how to write it? How to write the answer? We just show on the axis how to write it. In order to write it, we just write in this way. We say x either should be minus less than -1 and x larger than 4. So this is the answer. Okay, let's consider another example and more complicated one. We also can solve this equation by drawing the graph before moving to the another example. Let's see how we can solve it by graph. Let's draw the coordinate axis of x and y, okay? And then let's draw these two equation. Let's consider each of them as an equation. One is absolute value of 2x minus 3, and the other one y is equal to 5. Let's draw these two functions on the x y coordinate plane, and then let's see what it means graphically. Okay, so in order to draw this absolute value graphs and even the simple graphs, we need to use the simplest way is to use the t-table, x and y t-table, and say if x is equal to 0, what will happen to y? Y will be equal to 3. And we should say when y is equal to 0. That is important. When and how y will be equal to 0. In which case, in the case that x becomes equal to 3/2. In that case, y will be equal to 0, and you can see here easily. Okay, so now we have two ordered pairs, and we just show it, mark it on the coordinate axis. 1 2 3 4 5. Okay, let's extend it to 6. So here 2 points we have. One is 3/2, which is somewhere here, 0 and 3, and 3/2 and 0. So these 2 points, and then we extend it. Okay, we extend it. This is 1. Since it's an absolute value, the function of absolute value cannot be less than 0. So it does not go below the to negative part of the y-axis. Okay, so therefore we need to mirror it or reflect it back. So this, now we just draw graphically y is equal to absolute value of 2x minus 3. Okay, and the other one is y is equal to 5, which is quite easy. We draw it here. And then what it means to absolute value of, let me write it here, 2x minus 3 is larger than 5. What it means is the area which this function, absolute value of 2x minus 3, is larger than 5. So here is the 5. This area, which I am showing it until negative infinity, this is above y is equal to 5. Therefore, this area belongs to our answer. And then if we find the value on the x-axis, these are the critical axis that critical values that we have already found it here, and this is the answer. One is -1 and the other one is 4. Okay, now let's consider another example and see if this method works for any kinds of inequality, absolute inequalities or not. So let's do another example. Suppose absolute value of 2x plus 3 is less than equal than absolute value of x minus 3. So again, the first step is to consider this inequality as equality. So we change the symbol or sign as equality. So we rewrite it again. 2x plus 3 is equal to x minus 3. And then now here we will get two possibilities. And two possibilities are 2x plus 3 is equal to x minus 3, one by positive and the other one with the negative value. 2x plus 3 is equal to negative x minus 3. Okay, so by solving that we will get, here we will get x is equal to -6. This is one of the critical values, and the other one here we will get 2x plus x plus 3 is equal to 3, which is x will be equal to 0. This is another value, critical values. Okay, now next step is to draw the axis. How to draw the axis? We just simply draw the axis. Okay, and then what to do next? Then we will just mark the values here. So let's say here is 0, 1, and here in -1, -2, -3, -4, -5, -6, -7. Okay, Now show the we need to now show the critical values by solid circles, because the sign here is less than equal, so that means critical values are also included in our answer. If we are not sure, we need to again check the critical value in the original inequality to see whether they are included or not. If they satisfy the inequality, they are included in the answer. If they do not satisfy the inequality, whether they are the critical values, but they are not included in the inequality in the answer. So therefore, since they are included in the answer, we just mark them by a solid circle. It means filled, okay, color circle. This is 0 and this one is -6, okay. Now next step is to approach these critical values from -infinity and from +infinity here. Let's see which of them works, and how to do that is we need to just substitute one value less and one value more than that critical value, and here is again the same thing, one value less and one value more than the critical value, and see if they work. Okay, so let's go ahead and start with the x is equal to -6. So if we say, let's just say if x is less than -6, it means we are approaching from the -infinity, okay, and x is equal to -7 or -7. Okay, let's see what will happen in the equation. So we substitute there, therefore absolute value of 2 -7, okay, plus 3 less and equal than absolute value of -7 -3. What will happen? Here will be -14. -14 plus 3 will be equal to -11. Okay, absolute value of -11 is less than equal absolute value of -10, which is wrong. No, so this is not correct. Therefore here this area is not included in our answer. Okay, so here is no. Therefore let's check the other side. So let's say if x is larger than -6, and let's say x is equal to -5, what will happen? Then absolute value of 2 times -5 plus 3 will be less than and equal -5 -3. Let's see if it works. Okay, and here it will be equal to -7. Absolute value of -7 is less than equal is less than actually negative absolute value of -8, which is correct, is less than, actually is not less than equal, but it's less than, and it works in the original inequality. So therefore in this area belongs to the answer. Okay, so let me erase this part. This area belongs to the answer until the other critical value. Okay, this area. Okay, Now let's, in order to make sure this is a correct answer, let's check one more value than the another critical value is, which is 0. Okay, so let's check if this area belongs to the answer or not. So let's say if x is equal to 1, which is larger than the other critical value, and see if it works or not. So therefore then it will be absolute value of 2 times 1 plus 3 is less than equal 1 minus 3. Let's see if it works or not. So it will be 2 plus 3 less than 2, which is not actually, So the answer here is for this inequality is, we will write it in this way. So let's we will say x is larger than -6 and smaller than 0. So this is the answer for this inequality. Okay, so this is how it works, and by solving this way has 0 error. It means you will not get any answer wrong. Okay, and you may ask whether this method works for those modulus inequalities that contain fraction or not. Yeah, it does work for those inequalities which contain fractions, but you need to exclude the undefined values, the values which make the fractions undefined, which are the roots of denominators of the fraction. Okay, those numbers, those values. All right, that's it. Thanks for watching this video.